That'd be a horrible soundproof.
Bye, guys. All right, 16 was G. Does anybody need me to go over how we got 16? Put your phones up. Does anybody need me to go over number 16? Yeah? Okay, the easiest thing would be to make that an improper fraction. So 5 times 3 is 15, plus 3 is 18 over 5 equals x plus, let's make this one, 3 times 2 is 6, plus 2 is 8 over 3. Y'all okay so far? How do I get x by itself? What would I do? Subtract it. There you go. All right, let me show you an ACT shortcut. You ready? 18 divided by 5 equals minus, parentheses, 8 divided by 3. 0.933, right? Y'all okay? Okay. 4 divided by 5 does not match. 14 divided by 15 does match, okay? Because I know most of you, and most of you that's probably faster for you to do. Kamara, if it's not something important, bye. What? I don't have any cash, baby. What do you need money for? Do you know, there's a water fountain.
That's not going to work for me.
Beggars can't be choosers. Okay, what about... Bye, dear. 17. 17 should have been A. Does anybody need me to go over 17? Anybody need 17?
No.
Yes? No. A system of linear equations is shown below. Which of the following describes the graph of these? So, guys, in order to graph these, what would you need to do? No. What would you need to do to these first? You need to divide them all by 3 first. So the first one would be y equals negative 2 over 3x plus 8 over 3. The second one would be y equals positive 2 over 3x plus 8 over 3. Are y'all okay with that?
So did you have to
Yes.
put it in like this?
Yes, you have to do that. All right. So what do you notice about these two numbers right here? They're the same. What else do you know about those two numbers? What is 8 over 3?
That is the y-intercept.
That is the y-intercept. In other words, these two lines are going to do what? Intersect at the y-axis at 8 over 3. Okay? So they are not parallel because they intersect. So it cannot be B or C. They do not have positive slopes because one's negative. It's not a negative slope because one's positive. So the only one that's left that intersects is A. Are y'all okay?
That seemed really overcomplicated to me.
No, it's not overcomplicated.
I mean, compared to what I.
Well, you could probably divide by 3 in your head and see.
I mean, I didn't even do that. I just looked at the slope and saw that one.
You had to know that the slope, what the slope was by dividing by 3 first.
I haven't been shown the schedule thing in Coach Miles.
Okay, who were you with?
Coach Miles.
No, like
what
counselor.
I don't know.
What's she look like? Okay.
I don't know.
That's Dr. Mosley. Yeah. Real pretty hair.
Yeah.
Okay. All right, here we go. 19. 19 should have been D. Does anybody need to go over that one? Anybody need D?
Yes, please.
Yes? All right, let's see. Okay, so it's rotated 180 degrees about the origin. Guys, where's the origin? In the middle. So in other words, you got this little piece over here. So if I rotate it about the origin, where is it going to go?
Upside down on the other side.
On the other side, right? So I need the left side. Well, A is not on the left. B is on the left. C is on the left. D is on the left. E is not on the left. Are y'all okay so far with that? Okay. Also, shh. It was rotated 180 degrees. So Matthew, what does that mean if it's rotated 180 degrees? You just said it. It's upside down. So instead of an M, it's going to be a W. So the one that's upside down is not C or B. It is D. Are y'all okay with that? All right, what about 20 is the last one? 20 should have been, you should have gotten an F. Does anybody need to go over 20? Wasn't that same problem in the last ACT packet we did?
No.
Or if it wasn't, it was real similar. One of the two. Well, that might be it. That might be a hint right there. If it's on two different ones. Okay, so go ahead and put that up. We're going to do one short little lesson today. It's not very difficult. It is not very long. It should be, depending on how much you remember from geometry. If you don't, ooh, that doesn't sound very good.
Yeah, I remember Pythagorean.
Wonderful. Okay, the wonderful thing is that we're not doing any geometry. We are doing trigonometry. All right, so y'all ready? Let me grab my paper to make sure I don't miss anything.
Okay, so this lesson,
Yeah.
case number 5, is it like?
It's you just take it in there because it's saving paper, not paper, copies.
Oh.
Because that back of that one is blank. So D, if I were to copy that, it would cost me an extra copy for nothingness. So, okay, you might want to grab yourself a highlighter. Where'd my highlighter go? Here we go. You ready? Bless you. All right, what was the little catchy little phrase, sing-song kind of a thing to remember trigonometry? SOHCAHTOA. There you
Keep the sum of a large number, then you'll be exact.
That's not SOHCAHTOA, dear.
That was 7th grade.
Yeah. That's not trigonometry, dear.
SOHCAHTOA.
We're going to learn the opposites. If you look down here, you remember that sine is opposite over hypotenuse, cosine is adjacent over hypotenuse, and tangent is opposite over adjacent, right? Those are nothing new? Okay, the new ones are just as easy, and I don't want you to remember anything. All I want you to do is know the opposites, because if you know which ones are opposites, you don't have to remember anything. You just flip them, okay? So look, cosecant is the opposite of sine. That's why they're stacked on top of each other, okay? I don't want you to remember that that's hypotenuse over opposite. I want you to remember that it's opposite of sine, and you just switch these two, okay? So don't try to remember all 6 of these. Just know that these are opposites, so you switch whatever sine is. Does that make sense? Kind of? Okay. All right, secant is how you pronounce that. So this one's cosecant. This one's secant. Secant is opposite of which one? So you don't have to remember anything except for that it's opposite of cosine. So you just switch what cosine is. Instead of adjacent over hypotenuse, it's hypotenuse over adjacent. All right, cotangent is pretty easy, right? Cotangent's the opposite of tangent. That one's pretty easy to remember. So you just switch the tangents. All right, so let's do some stuff with these. You ready? It says to do what in the directions? All 6 of them, right? But we're not going to remember all 6 of them. We're only going to remember what 3? Sine, cosine, tangent, right? The other ones are just opposites. Here we go. So we're going to go off of this angle theta, right? Remember that theta symbol from geometry? All right. Sine is from here. Sine is opposite. What's on the opposite side? 5 over hypotenuse. What's the hypotenuse? 13. Y'all okay? No, it's 5 over 13. Opposite over hypotenuse. Do not complicate things. We're not there yet. All right, cosine, you ready? So cosine is adjacent over hypotenuse. Adjacent is right here. We don't know this one. So how do we figure out that side of that triangle? Pythagorean theorem. Here we go. So 5 squared plus b squared equals 13 squared. You remember that trick I showed you? 13 squared. How am I going to move this 5 squared? So subtract 5 squared. Do it real quick like, okay? So b squared equals 144. So what is b? 12. There you go. So this is 12. Okay. So what is cosine? Whatever what? Okay. So what's my adjacent to theta? 12 over my hypotenuse. 13. All right. So my tangent. Tangent is whatever what? There you go. What opposite is? Adjacent is? There you go. Y'all okay with that so far? Okay, then all you have to do is remember which ones are opposite. So Matthew, what's the opposite of sine?
13 over 5.
Very good. So cosecant, you just switch it. 13 over 5. Y'all okay? Okay. What's the opposite of cosine? Secant, which is? You just switch it, right? And this one's the easy one. What's the opposite of cotangent? Of tangent, sorry. Cotangent, sorry. Which is 12 over 5. Y'all okay? Pretty easy stuff. So you want to know the way I remember which one's which? The what? What? What'd you think of? No. So when we get finished, you can. Remind me when you get finished. So the way I remember it, they have opposite letters. So like sine and cosecant, one's an S, one's a C. One's a C, one's an S. So if that helps you, and then Matthew's going to do something for us in a minute to see what he remembers it. Okay, let's do number 2. Ready? All right, I got to find this missing side. This missing side is my hypotenuse. So it's 12 squared plus 16 squared equals C squared. Here we go. 12 squared plus 16 squared. Plug it straight in your calculator. What do you get? 400. And what's that mean C is? 20. There you go. Alright, so sine of theta, here we go. Sine of theta is right here. Yes, ma'am.
Would it just be beneficial every time to work out the Pythagorean theorem first?
Yes. Unless, if it tells you to find all of them, yes. If it doesn't tell you to find all of them, then it may not be beneficial to do that first. Okay, so here we go. What's sine? Whatever what? Opposite over hypotenuse, which is 16 over 20. Ooh, but that reduces by 4 to give you 4 over 5. Very good. All right, off the same angle, cosine. Cosine is adjacent over hypotenuse. What's my adjacent over hypotenuse? Over. Those reduced by 2. No, that reduces by 4 again. I'm sorry. To give you 3 over 5. All right, tangent, what's tangent? 16 over what? 12, very good. Those also reduced by 4 to give you 4 over 3. Bless you. Y'all okay? Okay, what's the opposite of sine? Which one? Cosecant, very good. Just switch your sign. Instead of 4 over 5, it's 5 over 4. Okay, what's the opposite of cosine? Secant. So switch your 3 over 5 and you get 5 over 3. Alright, what's the opposite of tangent? Cotangent. Switch your 4 over 3 and you get 3 over 4. Y'all okay with that? Think you can try number 3? Yeah? Okay, try number 3. I told you today wasn't difficult. Okay, guys, look, one thing that I see right here. This is not theta. That is not theta. What's wrong with that? You have to put the little thingy in the middle, right there, to make it look like a theta, okay? You have to put the little mark in the middle of it. Alright, so find all of them. Use the Pythagorean theorem. Find that missing side. you get was the side? 15. You should have gotten the square root of 225 is 15. Very good. All right, Josh, what did you get was the sine? 8 over 17. Brinkley, what did you get was the cosine? Perfect. Sydney, what would you get would be the tangent? Perfect. Okay, Madison, what's the opposite of sine? Which one? Cosecant. And Michaela, what would be the cosecant, whatever what? Perfect. All right, Gracie, what's the opposite of cosine? Secant. And Anthony, what would be your secant?
17 or 15.
Perfect. Okay, Emily, what's the opposite of tangent? Cotangent. And what did you say it was? 15 over 8. Y'all okay? Pretty easy, pretty simple. So the only thing new were the cosecants, the secants, and the cotangents. Okay? All right, let's flip over on the back real quick. Uh-oh. I know. A little different. All right, we're going to do this page, and then we'll call it a day, okay?
Okay.
All right. Okay.
And then 9 weeks.
And then one more 9 weeks, and then we're done. No, we kind of switched Trig a little bit, so we're not gonna do Trig for the entire quarter. We'll have to do one more chapter. Okay, here we go. You ready? So first thing that I would do is I would draw a triangle because it tells you which angles are which. Now, in order to do sine, cosine, and tangent, what kind of triangle do you need? A right triangle, okay? So it tells you that in a right triangle, angle A and angle B are acute. So where does that mean that A and B and C are? C, well, C is the right angle. Yeah. And does it matter where A and B go? No. Nah. All right, here we go. So it tells you that if tangent of A is 7 over 12, so what angle am I going off of?
A.
The A, right? Okay, so from A, tangent is 7 over 12. Guys, what is tangent? What over what?
Opposite over A.
So the opposite is 7.
C to B.
Uh-huh. And where's the 12 go?
A to C.
Perfect. Y'all okay? All right. So Madison, here's what we need to do. It says, what is cosine of A? You were asking, sometimes we don't need to do this one. So let's see, cosine is what over what? Anybody? Opposite over hypotenuse. So yeah, we are going to need to do this, okay? So if they were...
Adjacent over hypotenuse, my bad.
What did we say?
Cosine is adjacent over hypotenuse.
Yeah, what did we say?
I said opposite.
To be honest, I was really only listening for the hypotenuse part. I'm sorry. Okay, so Madison, we need the hypotenuse. So in this case, we would need to do it, okay? Okay, so here we go. So it's 12 squared plus 7 squared. That, 193. Is that a perfect square? No. So how do we write that? Square root of 193, because I do not believe there is a perfect square that divides into that.
Are we going to have to figure it out?
Huh?
Or can we just put
I do not believe there's a perfect square that divides into that. That's what I just said.
No, because like last year we had to do this whole thing.
Well, let's see what we're doing. You ready? Cosine. We're doing cosine. Y'all okay? And what angle are we going off of? A. So cosine of A is adjacent, which is 12, over Ooh. What's wrong with that? Y'all so smart. How do I get rid of it?
Multiply by the reciprocal.
No, we do not. You do not square both. Come on, guys. How do we rationalize the denominator? Multiply it by what? Square root of 193. And if you do it to the top, you got to do it to the bottom. But if you're real smart, you can do this in one step. You ready? Can I multiply 12 and 193? Yeah, combine them. You smoosh them, right? Smoosh. So, guys, look. Think about this. You could do this. Huh?
Or is that just...
Oh, I don't know why. I did that. Okay, so if I were to multiply square root of 193 times square root of 193, what do you get?
193.
You just get 193. Do those cancel? Nope, you're done.
Well,
Say,
yeah.
No, they
Well,
don't.
193.
Because one has a square root and one doesn't. And 12 and 193 don't reduce. Okay, let's do 2 together. You ready? Okay, so first thing I would draw my triangle so that I could see what's what. So we already know that this is A, this is C, and this is B. Okay, what angle are we going off of? Angle A, because it said cosine of A, right? Cosine is adjacent, which is 1, over hypotenuse, which is 2. All right, how do you plug it in your calculator? You would do 2 squared, subtract 1 squared. Guys, if you still need to write this out, write it out by all means. But I know most of you, 1 squared plus b squared equals 2 squared. You're going to subtract 1 squared. Like I said, if you still need to write it out, do it. What'd you get? 3. So that's the square root of 3, right? All right, what are we doing? We're talking about an tangent of A. Guys, you got to be careful about what angle it's wanting you to go off of, okay? Because that can change your answer dramatically. So what angle are we going off of?
what?
2 squared minus 1 squared is 3. Get rid of the square, you square root. And that would be square root of 3. What's 2 squared? What's 1 squared? What's 4 minus 1? 3. Now how do you get rid of the square? You square root. That's how I got square root of 3. Okay, what is tangent?
Whatever square root over hypotenuse.
Opposite over hypotenuse, okay?
What?
Over a
Not a J. Golly.
Sorry.
Gosh. Okay, so what is that answer? Just square root of 3. Is that okay?
Yeah.
Yes, because that's not in the denominator. So that's okay. Are y'all good with that? No?
Not really.
This is just geometry. This is nothing new. This is what you did last year in geometry. Well, we might need to come to 0 period. So let's do this very slowly. If you want to do number 3 on your own, then do it. If I don't need the sound effects. If you need to do it together, then let's do it together. Okay, what angle does it tell us to go off of this time? B. So which is this one, okay? That's very important because you could get a completely different answer if you go off of a different angle. So sine is what over what? Opposite over hypotenuse, which is sine is opposite over hypotenuse, which is 3 over 8. Okay with that? Okay. So then you have to find this missing side. So 3 squared plus b squared equals your hypotenuse squared, which is 8 squared. It's just Pythagorean theorem. What? What? Are you okay? Okay. All right, now how would I move this 3 squared to the other side? You would subtract it. So in your calculator, you're going to do 8 squared, subtract 3 squared. So that would be b squared equals 55. Now how do I get rid of that square? You square root. So this is square root of 55. Y'all okay with that?
Like, say there was a perfect square that goes in there, would you have to figure that out?
Yes, but there's not one on these. Okay, so what's it want us to do? Tangent of B? Okay. So this is a big deal. This tells us what letter to go off of, what angle. So we're going off of B. Tangent is opposite, which is 3, over adjacent, which is square root of 55. All right, you cannot have a square root in the bottom, so what would we do? There you go. Okay? So Sydney told us earlier that we can just smush these together. We can just put them together because can't multiply them. And what is the square root of 55 times the square root of 55? Just 55. And if you need to use your calculator, do it. And it'll give you 55. Are y'all okay? Will the 55s cancel? Will the 3 and the 55 reduce? No. So we're done. Are y'all okay? Did you got it good? Okay. All right. That's all of our notes we're going to do today. Okay. I'm going to hand out your tests. I don't know why you groaned, and they were actually pretty good. For the most part. There was a few that were, but for the most part, they were pretty good.
I got my this class or
Both. What, Matthew?
Can I do the screen now?
Yeah, go down on the board now, Matthew.
Oh, guys, this is amazing.